Welcome to Check Point Jumpstart training series. In this training module, we will examine the CloudGuard capabilities called the CloudGuard Private and Public Network Security. CloudGuard Network Security is used to protect both your private and public cloud network assets. Lesson 3, CloudGuard Segmentation. In this third lesson, we're going to learn how to use CloudGuard firewall rule bases and some creative cloud routing to help segment your cloud networks. Now let's talk about CloudGuard segmentation. The word segmentation can have multiple meanings in network terminology, but here I'm referring to the meaning that networks are isolated from each other. So if one machine is compromised on one network, it can then compromise other machines on the same or other networks. CloudGuard can be used to protect and inspect your cloud environments in what we call a north-south virtual clouds configuration, and also between your virtual networks in what we call an east-west data flow configuration. In the next few moments, I'm going to explain what I mean and how these traffic flow configurations can be used to protect your networks. North-south segmentation refers to egress and ingress inspection perimeters, meaning here we are inspecting traffic to and from your virtual cloud environment. The North Perimeter Hub would be hosting any public cloud assets that would be public facing, and here most traffic would be leading from and to the internet. The South Hub will be hosting all your private cloud assets. These are your internal only assets, for your eyes only, so to speak. And from here, most assets would be accessible to and from your organization, head office or branch offices, and your company personal and private assets would be stored here. East-west refers to lateral traffic movement. Traffic that is moving from one cloud network to another cloud network. This can also refer to traffic movement within the cloud, from one subnet to another subnet, from one virtual private cloud to another virtual private cloud, from one availability zone to another availability zone, from one region to another region. This lateral movement would mostly be accessible and accessed within the cloud provider's backbone. No traffic would be forwarded to or from the internet. And then we would inspect traffic at different cloud and network perimeters. As traffic is flowing between different cloud perimeters or moving between your virtual networks or your virtual workloads, ideally we would have a CloudGuard gateway at each perimeter's edge. Most traditional network segmentation protects your assets from the north-south perimeters, meaning ingress and egress traffic. But what is different in the cloud is that now, with CloudGuard solutions, we can even protect both your assets from north-south and also from east-west perimeters. East-west segmentation is an additional security solution that adds an additional layer of protection into your network that you cannot do with traditional networking. But you can do this in the cloud by taking advantage of some very creative routing, which we will discuss shortly. So now let's take a look at how to segment your assets in the cloud. In this video, I'm going to focus on the public cloud. Even though you can do both north-south segmentation and east-west segmentation in both public cloud solutions and also private cloud solutions, the implementation is different. The concept is the same, but how to achieve it varies between private cloud solutions. So for now, private cloud is out of the scope of this training series. Let's now first take a look at the north-south perimeter inspection. The north perimeter is your internet-facing hub. This is where you assign workloads that are accessible from the internet. Your customers will be able to get to your internet-facing assets, such as your web servers, your database servers, your marketing servers, or any other servers that you want them to be accessible from the internet for your customer base or for the general public. So you want to be extremely sure that you have the utmost protection with the highest level of security in this north perimeter. And in addition, and I have alluded to this a few times, depending on your business demands, this northbound hub can be scaled up during business peak hours or scaled down during slow downward trends. The North Perimeter Hub is where your internet-facing CloudGuard firewalls will be located. This is your public-facing hub, and this is where you protect your assets that are accessible from the internet. Here is where you define your access control rules, your users' identity permissions to your public cloud assets, and here is also where we inspect traffic with threat prevention blades to prevent breaches into your cloud networks. For obvious reasons, no northbound traffic should have access permissions to your cloud infrastructure. They might have only access to your public-facing data, your web servers, your databases, but you want to be sure that there is no access to your cloud infrastructure. And this includes load balancers, firewalls, gateways, workloads, and so only approved protocols, services, and applications will be allowed. And this is true for any network, be it public, private, cloud, or traditional networks. And of course, all other unapproved protocols would be dropped at the perimeter, and so only access to the data on the servers will be allowed, and any access to the servers themselves would be dropped, like RDP connections, for example. Now let's take a look at the South Hub. Here is where most customers create what we call a southbound perimeter. This perimeter, in general, will not be public internet-facing assets, and so it would not be allowing traffic from the general public, but instead, even though these assets are still stored in the cloud, these would be assets that should only be accessible from and to the organization. These are company-facing assets, assets that would be accessible from the many of the company's various locations, different locations such as the headquarters, branch offices, or the company's data centers. And they may be also accessible from and to other cloud regions or other cloud providers. All data leaving to and from this location would usually be encrypted through a native IPsec VPN or other encryption solution. And so for security reasons, only traffic sourced from the headquarters or sourced from the branch offices will be accessible through the southbound perimeter. Traffic could still be outbound to the internet, but mostly it would be for software updates or software patching. And so you would still need CloudGuard firewall located at the southbound perimeter to either accept authorized traffic, but obviously you would need to block any nefarious security breaching attempts. Again, let me repeat, so we can understand clearly the difference between the North Hub and the South Hub. In the North Hub, we have public-facing assets that we want to be available to the general public. In the South Hub, this is where you would store your private and confidential assets. No public-facing or customer traffic is allowed through the South Hub. Only private traffic to and from your organization is allowed. You might also allow outbound software updates, but no source traffic from the internet would be allowed through this southbound hub. So here, you would place a southbound facing CloudGuard firewall and only allow traffic sourced from your locations. Any traffic sourced from the internet would be dropped here. Now let's talk about east-west segmentation, which is completely different between north-south segmentation. The main purpose of east-west segmentation is to protect your assets in the cloud, in case an asset or workload has been compromised. In traditional network, once an asset has been compromised, then all bets are off. Once an asset has been compromised, then the attackers will be able to spread and infect laterally between host to host. The same is true also in the cloud. Once an asset has been compromised in the cloud, attackers are able to spread laterally from virtual machine to virtual machine, or perhaps even extending their reach into the corporate networks. But in the cloud, we can add another additional security protection, what we call east-west segmentation. With east-west segmentation, when a host tries to communicate to another host on the same private cloud, it cannot do so directly. It first needs to go through the CloudGuard gateway for access permissions and threat inspection. If it is accepted, then the traffic is allowed. And even if the hosts are directly and physically next to each other in the same subnet, we can still prevent lateral movement in what we call the east-west traffic flow to secure the cloud assets. This is also what we usually call micro-segmentation. The workloads can be directly connected to each other, and still, all traffic flow must first go through the CloudGuard gateway for approval, for access control permissions, and also threat prevention inspection before routing to its final destination. As mentioned already, this kind of segmentation is not possible in traditional networks. This is only possible in the cloud. So how do we do this? Again, I'll repeat to be sure this is clear. We take advantage of special native cloud routing rules and creatively segment the workloads. So even though the workloads might be on the same network, we're using very creative routing solutions to make sure that when the workloads need to communicate to any other workload on the same network, the traffic first needs to be routed to the CloudGuard gateway. For a complete rule-based analysis that defines what workload traffic is allowed and to what other workload and protocols are allowed. And in addition, the CloudGuard will perform deep packet inspection to make sure the traffic is benign and legitimate before routing the traffic to the destination workloads. Notice that in this diagram that even though host A and host B are on the same subnet, they cannot directly communicate with each other. That's because we created a routing entry in the routing table that says that the next hop is the CloudGuard gateway. So the source is host A, the destination is host B, but the next hop is the CloudGuard gateway. I'll show you how to exactly do this in the lab section of this training series. That brings us to the end of this lesson. Let's quickly recap before exiting this video. Lesson 3 was about CloudGuard segmentation. In this training module, we discussed how to do cloud network segmentation. In this lesson, we learned that we can secure traffic in the cloud using what we call segmentation. And we have a few kinds of segmentation. We have what we call the north-south segmentation, which helps direct and secure the traffic flow to and from the internet and also to the corporate offices. We also have a different kind of segmentation, what we call east-west traffic flow segmentation. And here we can segment traffic to prevent lateral infection, even though the workloads might be directly next to each other. We use creative cloud routing solutions and firewall rule bases to segment and protect the cloud assets. That completes our third lesson, and that is the end of this training video. I hope to see you in the next video. Until then, so long and goodbye.